Whenever there is a discussion about Tempdb, a lot of best practices pop up. Something like you should have trace flag 1117 turned on, you should have trace flag 1118 turned on, and Tempdb should be configured with multiple data files, etc. Now, all these are very popular best practices. If you just go to your favorite search engine and search about them, you will get tons and tons of blog posts and Microsoft KB articles, etc., where it is recommended that you should be turning on all of these things, which is basically enabling these so-called functionalities or best practices. Now, a lot depends on which version of SQL Server you are running. Now, the combination of the version of SQL Server that you are running and all of these best practices gives you a lot of permutations, and you got to understand that very carefully. Now, first things first, a lot of things have changed from SQL Server 2016 onwards. So prior to SQL Server 2016, you had to manually go and turn on these trace flags, 1117 and 1118. I'm yet to come to what exactly these trace flags do, so we'll discuss that in a moment. But just let me talk about the differences between different versions. So prior to SQL Server 2016, you got to turn these on manually, and from 2016 onwards, these are automatically turned on, which means Microsoft has made them as default behavior. Likewise, having multiple data files for Tempdb has been a very popular best practice for quite some time. And if you recollect, when you install SQL Server, let's talk about installing SQL Server 2012, 2014, etc. By default, you will see that you are able to, I mean, when installation is done, you would see that there's just one data file for Tempdb and one log file. But from 2016 onwards, you get this option of configuring Tempdb with multiple data files right from the word go, right from the installation. So the idea is that these best practices have been very popular, very common, and almost all SQL Server deployments will have all these kind of turned on and implemented. So it's like in all the latest versions of SQL Server now, as of this recording, the latest version of SQL Server is SQL Server 2022. So in all these latest versions of SQL Server, these trace flags are turned on, and during installation of SQL Server, you will see Tempdb is pre-configured with multiple data files. Now, let's first talk about these three best practices. So you have the multiple data files for Tempdb, trace flags 1117 and trace flag 1118. Now, all these three best practices are independent of each other. They're of course interrelated, which means that when you are talking about Tempdb, you're kind of working with all these three together, because just kind of turning one on and turning the other off would not give you much benefit. So trace flag 1117, when you turn this trace flag on, you are essentially telling SQL Server to fill all the data files in a specific file group proportionately, equally, which means when SQL Server is in need to grow a data file, and if there are multiple data files in a file group, all of them are going to grow equally. Unlike if this trace flag was not turned on, what will SQL Server do? Let's say your file group has 8 data files. It will first fill and occupy all the space, all the free space in the first data file. Then it will move on to the second one and third one, fourth, etc. Which means it will do that sequentially. Turning trace flag 1117 all means SQL Server is going to fill all of them equally and proportionately. Now, this trace flag will not have any impact on Tempdb if Tempdb has just one data file, right? That's why I mentioned that it makes sense that they are interrelated, and these three things you are kind of turning them on together. So you should have Tempdb configured with multiple data files. Then only trace flag 1117 will have that benefit and that impact. So what's the best practice with Tempdb in terms of multiple data files? You should, let's say, configure a minimum of 8 data files for Tempdb. Now, a typical best practice is you should have one data file per logical processor. So you could start with 8, go all the way up to 16, but probably not more than 16. You might have a box with 16 cores, 32 cores, 96 cores, more than 100 cores. Doesn't mean that you just follow the best practice of one data file per core or per logical processor, and you just keep adding those many data files. Doesn't make sense. So you may start with 8, go up to 16, and that's kind of pretty good enough. Now, if your question is, shall we have 32 or 64 data files? I don't know. You got to test all of that. But 8 and 16 is a safe bet. So when you have Tempdb with these many data files and you have 1117 turned on, they're going to be filled up equally and proportionately. And it helps in elevating Tempdb contention, because when you have your stored procedures and your code that are creating a lot of Tempdb, temporary objects, creating and destroying, which is dropping. So Microsoft SQL Server Engine is running a lot of allocation and deallocation code. And when you have all this allocation and deallocation code running in, SQL Server has to touch all these system pages like GAM, SGAM, PFS, etc. So having multiple data files really help, because then you have things running in parallel and it can improve performance. It can improve performance of your code that is allocating and deallocating objects. Then there is this trace flag called 1118, which is telling SQL Server to use full extents instead of mixed extent when you're creating new temporary object. Like for example, you're creating a new temporary table. Now, a page is 8K and 8 contiguous page make one extent, which is 64K. So in the world of mixed extents, pages belonging to an extent can be allocated to different objects. But when you turn on the trace flag 1118, then you're telling SQL Server that I don't want this space to be shared, which means it becomes private for that specific object. So yeah, these things will give you some performance improvement when you are working with Tempdb. So just a quick summary and a quick recap. 1117, 1118 are the default behavior, but also note that 1117 and 1118 is just not for Tempdb. If these are turned on, these become the default behavior for all the databases running in your instance. But we talk more about these trace flags in the context of Tempdb, because Tempdb contention in SQL Server has been a very popular topic of discussion, and that's why we continuously talk more about Tempdb here. So that's 1117 and 1118, and then comes having multiple data files for your Tempdb database. Basic best practice is to have one data file per logical processor, and you can go up to 16. So in this video, what am I going to demonstrate to you? I'm not going to turn on 1117 and 1118. I'm running SQL Server 2019 or 22, whatever, and these are already turned on. I'm only going to show you the performance benefit of having a single data file versus multiple data files, because we constantly keep talking about it and we read a lot about it, but I just wanted to practically show it to you that yes, it does have an impact, and having multiple data files definitely improves performance. So let's jump now into the demo. There are a few files here, if you see in my demo harness, which is one_tempdb file. So first I'm going to open reconfigure Tempdb. Let's use Tempdb and let's see how many data files we have right now. So if I say select star from database files, let's go and execute, and you will see that there is one data file which is called tempdev, and there is another log file which is templog. So I have only one data file and the other one is the log file. Now this is the default scenario right now, and now what I'm going to do is run a workload and record the performance, typical baselining and benchmarking, record the numbers, record the metrics, and then add more data files and then run the same workload again, so you are able to compare. So we are all good to start the demo with one data file. Now what is my demo doing? So let's go and open this batch file, In this bash file, as I always do, if you have been following my videos, I use RML utilities to stress SQL Server. RML utilities has an executable called ostress, and ostress utility is going to call a file called temptable.sql. There is some code inside it, and I'm going to show that to you in a moment. And we are going to create 20 threads, and each thread is going to call the code in this SQL file, and it's going to repeat 5 times. So these are your parameters, -n and -r. So let's go and close this. So this is like 20 into 500 executions. Should complete in less than a minute, I hope so. Now, what's the code in temptable.sql? If I open this, we are going to use AdventureWorks 2016. And if you look at this code, it's a very, very straightforward code. We are creating a temporary table here, and we are inserting some data into this temporary table, and then we are dropping the table. Very, very straightforward, which means each execution is going to create a temporary object, fill some data into it, and then drop it. Which means we are purposely, and of course it's an engineered demo, we are purposely forcing SQL Server to run the allocation code, object allocation code, and object deallocation code. This is just to create contention. And we are going to see what, and yeah, you know, we could also go and look into weight stats, details, etc. But then maybe that could be done in another demo. But yeah, we are actually causing contention, and that is going to introduce delay in the overall execution. It's going to introduce some weight there, right? So this is the code that's going to run. Let's close it. And now let's go and fire this file. Yeah, it's not 100 users. Why not just go and rename it so that it looks more appropriate? This is going to be 20 users. So I'm just going to make it realistic. Add 20 users. 100 users is just going to take a lot of time. So let's double click and run this. Okay, with one data file in Tempdb, now you are stressing SQL Server, and let's turn on performance monitor here and look at CPU utilization, and you can see that CPU is being utilized now for this execution, and it's not really choking SQL Server. It's just very average utilization going on right now. Some processors are being used, not really all of them, because if you see right at the bottom, there are 8 logical processors here, and if you see this one at the end, it's not being CPU cycles here are not as much as what I see in the other ones. Any which ways, this is working fine. It's running. Let's see how much time this takes. And if you can see the note here, it says creating 20 threads to process the queries. Okay, we got to wait for a few more seconds before this execution is complete. Okay, we are done. Wow. So let's go and look into the numbers. This has taken 1 minute 6 seconds. This is the overall execution. So 20 threads, running that code inside temptable.sql, and running each thread doing this 5 times. This was the total test harness, and with one data file, you know, all of these threads going and allocating, deallocating, creating the object, destroying it, took 1 minute 6 seconds. What are we testing really? What is the objective of this demo and this video? We are going to look at performance difference when you have one data file with Tempdb versus multiple. Now, if you look at the CPU graph here, there are 8 logical processors, and just going by the best practice, you can have one data file per logical processor. So we already have one, which means we can add 7 more, so that the work that we do on those data files gets equally distributed on these processors. So note the time, 1 minute 6 seconds, which is about 66 seconds, right? 66 seconds. Press any key to continue. Let's close the window. Let's keep this on in background. And what are we going to do? Go back to Management Studio, reconfigure Tempdb. Okay, so here is a dynamic SQL code where we are going to add 7 data files. So I've already written the code. I won't get into explaining you the code. It's pretty straightforward, just trying to figure out what the file names are, what the path is, and then dynamically generating the file names, etc. That's what we are going to do. So let's go and execute this piece of code. Hopefully there are no errors. Okay, looks like this is done. And I am going to select star from sys.database files, and you will see, yes, we're all good now. So accepting this one file, which is the log file, now you can see the total count being 9, which means we have 8 data files. Look at the type description there, rows, 8 data files. Now what I'm going to do is I'm going to restart SQL Server now. You know, Tempdb is a throwaway database, right? I mean, it doesn't do recovery. So everything that is there in Tempdb will be removed. It is going to be recreated again. I'm doing that just so that all the data files that we have in Tempdb now will have a equal starting point. So restart is done. Let's go and execute this. Just do a check once more. Yes, we are good with 8 data files, right? All good. Now we are going to run the same code again. Remember last time it took 1 minute 6 seconds. Let's go and double click this. And now you will have the same allocation and deallocation code running. But now this work is being spread across 8 data files, right? And this is the kind of alignment we are talking about. We're talking about each data file being aligned to a logical processor, and things should go faster. Everything was happening in one data file now, and that work gets distributed to 8 data files. And then proportionate fill algorithm is also kicking in here. So all 8 files are going to grow up equally as we allocate space and as we create objects. Let's go and look into the task manager now. So here you will see all 8 processors are being utilized. And let's see, are we getting any performance gain in the overall execution? You know, if you look at the code piece that I have here, there was something called as Tempdb contention. You know, I was wanting to show this to you as well, the page latch contention, but yeah, I just skipped that. Okay, so now if you look at the code there, this is 57 seconds. Not much of difference there, but this is still something. So 1 minute 6 seconds comes down to 57. So 66 seconds come down to 57 seconds, which is about 9 to 10 seconds of benefit. Now, first things first, yes, there is a performance improvement here, but you might be expecting that, oh, this performance improvement should have been, you know, drastic and should have been much better. Not really. A couple of things to keep in mind, that the VM on which I am running this demo already has a very fast storage, right? It is powered with SSD, and Tempdb is placed on that SSD. So the storage is already pretty fast. That's the first thing. Second is the amount of work we are doing, right? And this simple test harness of creating an object and just allocating and deallocating it is not very realistic in terms of actual production code. So if you look at the volume of work that you're going to do in Tempdb, and you know, when we work with Tempdb, we are dealing with, you know, hundreds and GBs of, you know, allocation and deallocation. That is where you are going to see much higher magnitude of performance difference. Now, this exact same demo I was running on a slightly older laptop that also had an SSD, but a slightly older laptop, and the performance difference was something like 37 seconds with 8 data file versus close to 1.5 minutes with just 1 data file. So a lot depends on the hardware and of course the volume of data that you are dealing with. But at least with this little demo here, you get the sense that yes, this best practice should be implemented. So coming back to this again, and this is one of the best practices, the immediate things that we do post SQL Server installation, right? We DBAs have a checklist, right? Immediately after SQL Server installation, there are things to do, and this is one of those things, right? Add multiple data files to Tempdb, which is reconfigure Tempdb with multiple data files, turn on trace flag 1117 and 1118, so on and so forth. So if you're on older versions of SQL Server 2016, make sure that all this is done. If you're on latest versions of SQL Server beyond 2016, probably this would already be done. But if not, then make sure that these things are in place. Having multiple data files, just not for Tempdb, but even for your user databases aligned to logical processors on your hardware does make sense and improve performance. Hope you enjoyed this demo. If you're watching this on YouTube, please be aware that now we also have a member only section. If you check out the playlist, which is member only playlist, you will see a lot of videos which are only meant for members. Those are advanced demos, advanced tutorials, and a lot of niche stuff available to you with a very nominal price. And also our recorded webinars, the premium paid webinars, recorded ones, are also available in that members only section. If you're watching this on SQLmaestros.com, SQLmaestros.com now has membership. So you have free membership with which you can watch all the free stuff, and you also have a premium membership. So all the premium videos and all the paid webinars are available in the premium section. Feel free to leverage whatever you think is good for you. Happy SQL! If you like the content, give it a thumbs up. Subscribe to the channel and click on the bell icon so that you're notified on new videos. Most importantly, visit SQLmaestros.com. There's a lot of SQL learning resources out there: video courses, master classes, lab kits, ebooks, blogs, hands-on labs, and a lot more. Follow us on Twitter @SQLmaestros and myself _Bansal. Last but not the least, do subscribe to our newsletters. See you soon in another video. Goodbye.